In this lab, you will construct a horizontal curve using data you yourself have calculated. You will be locating and marking all of the points you have calculated, beginning of curve, end of curve, and all of the intermediate points along the arc of the curve. When building the curve, keep in mind that errors accumulate. A small 1mm error at each step, for example, will easily add up to 12mm of error or more by the end. The total allowable error is only 10mm. Precision and accuracy are key. This is the layout of the lab. You have been given a PI, or point of intersection, marked as an X on a wooden stake. The PI is the point where the legs of the X intersect. This should give you a visual idea of the precision required in this lab. You have also been given the bearing for your BC, or beginning of curve. You can see the stake from the PI. The range pole will help you to spot it. It is also marked with an X, similarly to the PI stake. Remember, this is the bearing of the BC, not the BC itself. We will now discuss how to set up the instrument. Just as in the transit lab, you will be setting up the instrument over the station, in this case, the PI. You will align the instrument to the point where the legs of the X intersect, rather than a screw head as before. In this case, when setting up the tripod, you want to be sure that the legs do not interfere with your stance while using the instrument, or block your ability to tape measure the tangents. You should also ensure that the instrument is at a comfortable working height. Poor ergonomic setup here can introduce errors in the placement of both the BC and the EC points. Once the tripod is placed correctly, be sure to anchor the feet firmly into the ground. Please refer to the Transit Lab setup for a detailed video on how to set up the instrument. Once the instrument is set up, you can begin by locating and marking the beginning of curve. In this lab, precision is key. When taking sights, it is critical to be as accurate as possible. Remember, the errors accumulate. Using a pencil point to mark the point is the best solution to this problem. Place the pencil tip on the intersection point of the X and target the crosshairs of the instrument on the pencil tip. By doing this, the pencil can move out of vertical and the precision will not be affected. When taking a long-range sight, it often helps to put a sheet of white paper behind the pencil. This gives a better visual contrast and makes it easier to precisely target the point. The next step is to set the orientation of the instrument so that it knows where the zero bearing is. You should know that once the orientation is set, if you bump the tripod, or the instrument, or both, and knock them out of level, you will lose the accuracy of the bearing setup, so be careful when working around the instrument. First, you want to get the instrument into the proper mode to set the orientation. Press the menu button. Press F1 for Program, press F1 to select Surveying, press F3 to set the orientation, and press F1 for Manual Angle Setting. Using the optical sight on the top of the instrument, do a course alignment by targeting the range pole. While looking through the telescope, adjust the azimuth knob on the instrument so the field of view lowers. The bearing stake should come into view. Focus the instrument if necessary. As shown earlier, place a pencil on the intersection of the X on the bearing stake and align the crosshairs to the tip. Carefully, without bumping the instrument out of alignment, press F4 to zero the bearing. Then press F3 to save the orientation. Sight through the instrument to be sure the crosshairs have not moved off the target. If they have, repeat the previous step. Realign, zero the bearing, and save the orientation. Now press F4 to begin surveying. You have now saved the orientation and are ready to locate and place the beginning of curve point.